Hello, and welcome to another lesson from Level Up Mathematics. Today, we will be exploring the different similarities and differences of proportional and non-proportional relationships. So, linear relationships can either be proportional or non-proportional. A proportional relationship means that there is a constant ratio between the values of x and y. Now, let's kind of look in a chart form some of our similarities and differences. So, proportional relationships can be written in the form y equals k times x, where k is the slope or rate of change. For example, y equals 1/2 x, y equals 2x. Equations like this represent linear relationships that are proportional. Non-proportional relationships, on the other hand, are written in the form y equals mx plus b, where m is the slope and b does not equal 0. For example, y equals 1/2 x plus 5, or y equals 2x minus 7. Those are non-proportional relationships. Now, if you're given a table of values and you want to know whether it's proportional or non-proportional, what you need to remember is that the ratio of y to x is constant in proportional relationships. So, for example, in this graph, in this table, we have 5. The ratio of 5 to 1 is 5. The ratio of 10 to 2 is also 5. The ratio of 15 to 3 is also 5. And the ratio of 20 to 4 is also 5. So you have a constant ratio. The value of k would be 5. Constant ratio means the relationship is proportional. Now, in non-proportional relationships, the ratio of y to x is not constant. So if you get a table like this one, let's look at our first ratio, y to x, 7/1 is 7. Let's try another ratio here, 12 to 2. The ratio of 12 to 2 is 6. If the ratio is not the same for every ordered pair, this one is not proportional, because the ratio is not of y to x is not constant. Proportional. All right. Now, in a graph, I think these are the easiest to tell if they're proportional or not. A linear relationship that passes through the origin, or 0, 0, is always proportional. Okay? Now, any graph that is not linear and does not contain the origin is not proportional. So this graph, as you can see, does not go through the point 0, 0, so it's not proportional. All right. In example 1, it says represent the verbal phrase with an equation, table, and graph, and then tell whether the relationship is proportional or non-proportional. So in problem A, it says the value of y is 1 more than twice the value of x. The value of y is, so y equals 1 more than twice the value of x. So 2x would be twice the value of x, and 1 more than that would be plus 1. So I can already tell that this is going to be non-proportional because it's written in the form y equals mx plus b. But let's go ahead and fill out the table here. So if our x value is -2, that means we're going to multiply it by 2 and add 1. So 2 times -2 is -4. -4 plus 1 is -3. So let's plot that. -2, -3 would go right there. All right, now we'll plug in a 0 and see what we get. So I'm going to put a 0 right there. 2 times 0 is 0, and 0 plus 1 is 1. So that means we have a dot at 0, 1. And then last, we want to plug in a 2. So 2 times 2 is 4, and 4 plus 1 is 5. So we have a dot at 2, 5. So we do have a linear relationship. This is a linear relationship. But does it go through the origin? The origin is right there. It does not go through the origin. So this relationship is non-proportional. It does not go through 0, 0, and it's of the form y equals mx plus b. So it cannot be proportional. All right. Look at problem B. The value of y is, so I'm going to put y equals, the value of y is the quotient of x and 2. Now quotient means divide. So the quotient of x and 2 could be written like this. Y equals x divided by 2. So if I wanted to rewrite this, I could rewrite it in this form, because we know we have an understood 1 attached to our x. So those two equations are the same. Either way you write it is correct. All right, so I'm going to plug in these different values for x and see what we get. So we want to plug in a -4 here, a 0 here, and a +4 here. All right, so 1/2 of -4 is -2. So 1, 2, 3, 4, 1, 2. So that would go right there. 1/2 of 0 is 0. So that would go right there. Oh, we're going to go through the origin. That's going to be important. And then 1/2 of 4 is +2. So 1, 2, 3, 4, 1, 2. So our linear relationship would look like something like this. And remember, a linear relationship that goes through 0, 0 is proportional. Okay, why is it proportional? It goes through 0, 0, has the form y equals kx, where k is equal to 1/2. Okay. All right, example 2. Represent each situation with an equation and a table and determine if the relationship is proportional or non-proportional. Now, I did not do this before I started, but we're going to need a calculator here. So let me bring up my Desmos calculator, because we're going to have some decimals here we need to work with. All right, awesome. Okay, in example 2, it says, example 2a, a teacher bought sets of books at a cost of $15.95 per set. The teacher also paid a one-time shipping fee of $20. We want to write an equation for this and create a table. So let's start with the equation. So y equals $15.95 per set plus a shipping fee of $20. So there's our equation. Now, to create the table, we're going to come over here to our calculator, and we're going to put our equation, 15.95x plus 20. There's our equation. I'm going to hit this little gear button, and I'm going to create table. And I'm going to put the values of x that I'm wanting. So we're wanting to know 16, 20, and 24. We don't really care about these others, so I'll just delete them. Okay, there's the only numbers I need. 275.20, 339, and 402.80. All right. Now, what we want to do is decide proportional or non-proportional. So this relationship is non-proportional because the equation is in the form y equals mx plus b, which means it's not going to go through the origin. And if you look at your graph over here, you can see that the graph does not go through 0, 0. Okay, in fact, let me put a 0 right here. It actually goes through the point 0, comma 20. So way up here, you can see it goes through 0, 20, not 0, 0. All right. Problem B. A teacher bought markers at a cost of $3 per set. So our cost is y equals 3 per set, or 3x. Now we're going to create a table for this. So I'm going to put in my equation y equals 3x. Then I'm going to hit my gear, make a table, and I want to know 3, 9, and 12. I don't really care about any of those. I may put in 0 so you can see what happens when x is 0. All right, so our total cost for 3 sets would be $9. Our total cost for 9 sets would be $27. And our total cost for 12 sets would be $36. Now, is this relationship proportional or non-proportional? So if you look at your table over here, we can see that it does go through 0, 0. So this is proportional because our graph is of the form y equals kx, where k is equal to 3. All right, example 3. Determine whether each situation is proportional, P, or non-proportional, NP. All right, problem A. The amount an employee who makes $8.50 per hour earns in H hours. So the salary is they earn $8.50 per hour. So y equals 8.50x. So this would be proportional because the equation is in the form y equals kx. Proportional. All right, B. The weight in X weeks of a puppy that gains 2 pounds per week if its starting weight is 8 pounds. So y equals, our starting weight was 8 pounds, and then it gains 2 pounds per week. So this would be non-proportional. I don't know why I wrote NB. Let's see. I'll delete that. I meant to write non-proportional. All right. So this is non-proportional because it's not in the form y equals kx. Excuse me. All right. C. The cost of purchasing apples for $1.75 per pound plus a shipping fee of 16 cents per pound. Now this one's a little tricky because this problem we have y equals 1.75 per pound plus 16 cents per pound. Well, those are like terms that need to be combined. If you combine them, you get y equals 1.91x. So this one would be proportional because it is in the form y equals kx. All right, problem D. The cost of purchasing grapefruit for $1.80 per pound with a coupon for $1 off the total cost. So our grapefruit would cost $1.80 per pound minus a $1 coupon. So this would be non-proportional because it's not in the form y equals kx. All right. Example 4. Determine whether each relationship below is proportional or non-proportional. Now, in problem A, we don't have an equation, so we don't know what form of the line it is, and we don't have a graph, so we don't know if it goes through 0, 0 or not. So what we can check is the ratio of y to x to see if it's constant. So we're going to take 1.5 and divide it by negative 4.5, and let's see what we get. 1.5 divided by negative 4.5, and that's a constant ratio of negative 0.33 repeating. All right, let's try the next one. Negative 1 divided by 3. So let's check that. Negative 1 divided by 3. Ooh, this is looking promising. Let's keep it going. Negative 2 divided by x. So negative 2 divided by 6. All right, so far we have a constant ratio of y to x, but let's check the last one to make sure. Negative 3.5 divided by 10.5. We want to make sure they're not trying to trick us. So negative 3.5 divided by 10.5. And sure enough, the ratio of y to x was constant. So I'm going to put P for proportional, and then I'll put the reason why. Ratio of y to x was constant. All right, problem B. We have a linear relationship shown. We want to know if it's proportional or non-proportional. Now, to me, when I'm given the graph, these are the easiest problems to tell because all I have to do is put a dot right here at 0, 0 and ask myself, does the linear relationship go through the origin? If the answer is no, it is NP, non-proportional, did not pass through the origin. So it is non-proportional. And that concludes today's lesson, how to determine whether a relationship is proportional or non-proportional.